So, one of the outstanding questions we have is Elaine in Yate, and she asked, why is the only place on Earth without ants called Antarctica? Is it? Well, let's find out from a man who knows his insects. Dr. Edmund Hunt is from the University of Bristol. Dr. Hunt, good afternoon.
Good afternoon, John.
Thanks for joining me. What's your specialty, Edmund?
Well, I did a PhD about ants. What I'm working on now is actually robotics. I had a chat with you earlier in the year about how we're looking at insects like ants to get inspiration for engineering, building robots.
It's an interesting one, isn't it? Because the ant for us humans is something, well, let's be honest, we get slightly annoyed about. Ants are one of those things that annoy us because they always appear where you don't want them, normally in your house, or they dig up your garden, or you end up sitting down on a nice sunny afternoon, maybe in a park, socially distanced, of course, and all that, and then you find that you're quite close to an ant's nest. But they're very intelligent, really, really interesting creatures, aren't they?
Yes, they're very important actually for the environment. As sort of ecosystem engineers, they do a lot of good kind of aerating the soil and eating detritus and keeping the place tidy. So they're very successful animals.
Remind me if you could, Edmund, what can an ant teach you about robotics? What can we learn from ants that could teach us the structure of how because I mean ultimately I suppose we're hurtling towards a world where the role of the robot is going to be very important.
Yeah, absolutely. Well, one of the really interesting things about ants is the way they organize themselves. You know, you have ant colonies with maybe hundreds or even thousands of workers sort of serving their colony. And we're really interested in how they organize their work.
Right.
Because it's decentralized, right? They don't have orders coming from the top down, from the queen, telling them what to do. You go and pick up this bit of food, you go and do this bit of construction. It's what we call self-organized. So what we'd like to do is build swarms of robots to do things like maybe agriculture or cleaning the sewers or doing search and rescue after disasters. But if you've got so many robots, it's very hard to control them, right? And it would actually be better if they could organize themselves and figure out how to do it based on the jobs in front of them.
That's a really interesting proposition, because that's almost as if to say, Edmund, we're going to be thinking about robots that can, in broad terms, think for themselves.
Yeah, that's what we would call autonomous robots, autonomy.
That's not AI, is it? That's a different thing altogether, isn't it?
I think, well, AI can be part of it, artificial intelligence, but kind of our approach with what we call swarm robotics is not to have something really complex, but actually to get the robots following quite simple rules that are quite transparent,
right,
and easy to understand. Because we think that's how ants do it, for example. It's sort of like, if I see some food in front of me, I'll grab the food. Or if I see that the nest has been slightly damaged, I'll do some repair work now. It's not necessarily, thinking about things in great detail. It's what we call reactive control, kind of reacting to what's happening in their local environment.
Because that would be quite extraordinary, wouldn't it, Edmund? Because if, let's say, for example, you had robots behaving like ants who were picking crops, and they could identify at the moment that crop was ready to be harvested, as opposed to, and that's all they did, that then another group came in and did the work, the harvesting. That would be so efficient.
Yeah, potentially it could be. And it would be maybe easier for us to understand as users what they're doing. We can kind of make sense of it in a way that maybe more sophisticated AI can be a bit of a black box, so to speak. You're not really, it works, but you're not really
creepy.
Sure how it works.
Yeah, you mean creepy.
Whereas if you know what the rule is, it's a bit more transparent.
Yes, if they're looking after your strawberries, that's one thing. If they start to take over the planet, that's something completely different. Let's talk about the planet, because the question that was posed was about ants and why they aren't in Antarctica. Is that true? Are there no ants in Antarctica?
Yes, that is true. As I say, the ants are very successful.
Yeah.
They're actually on every continent of the world apart from Antarctica. So I guess
Haha.
it's kind of a slight joke to the question, isn't it? Because it's
Yes.
Antarctica. But no, there aren't any ants down there.
And why would that be? Just too harsh for them?
Yes, I think that's basically what it comes down to is one that it's extremely cold,
Yeah.
and probably two, there's not really much for them to eat either. Um, that would sort of be the short answer. But so I've looked up the temperature of the Antarctic. I mean, the warmest part of the Antarctic is around the coast, is about -10 on average. And as you go into the interior, it gets more to like -50.
Yes.
And as biologists, we can basically put animals in one of two categories. So we have warm-blooded animals, so mammals like us, human beings, or birds, they're warm-blooded. So what we can do is we can generate our own body heat, which means we have to eat a lot, basically, to kind of keep our inner metabolism going, to keep a constant body temperature. Or you have things like fish, amphibians, reptiles, or insects, like the ants. They're cold-blooded, and that means that they get their body heat from the environment. So as the environment warms up, their body temperature will go up, and as it goes down, their body temperature will go down. And so they're very much sort of at the mercy, unless they can kind of modify their behavior to respond to it, but they're kind of waiting for the environment to get the energy that they need to get moving. So the ants generally have like a daily cycle, really, waiting for the sun to come up to warm the ground, and then that kind of helps to set them off in the morning. If it gets too hot, they tend to retreat because they can't really control that. They'll overheat. So if you're going down to -10, -50, right, they would basically be frozen still because they wouldn't have the energy to get moving, and they'd have a very kind of stop-go lifestyle, waiting for the temperature to momentarily get up high enough to get moving. So there's not really much in the way of insects in the Antarctic.
Not really the right environment for an ant, Antarctica. Edmund, always a pleasure having you on the programme. Thank you very much for joining me. Good to talk to you again as well.
A pleasure. Thanks.
Thank you. Dr. Edmund Hunt there from the University of Bristol, all about ants. Claire Cavaliers with you from 2 this afternoon. Claire, good afternoon.
Hello, how are you?
I'm very
well,
well,
thank you. Are you going to play
you.
Adam and the Ants now?
No, I'm not that cliched.
No.
That and the fact that I can't get the mouse to work in here anymore. It's dead. Absolutely dead as a dodo.
Oh, come on.